Good morning, guys. Good morning, everyone. How are you guys doing this morning? How's everyone doing this morning? Guys, can you hear me? Okay, great. My stomach hurts. I hope you get well, Obegeng. I hope you get well. And how's everyone else doing today? How's everyone else doing? I'm doing very well, and it's actually cold. You are right. So, today we are continuing with electric circuits, but I want to find out from you guys, how is electric circuit so far? How is electric circuit so far, guys? You guys are so quiet today. What's wrong, guys? I'm just looking who's here. I have Obageng, Lydia, Luandle, Lind Rose, Lorraine, Hello, Kyle, Kayla, Joshua, Jed, Jared, and Jade. Okay. So I know today you can't see the chats from the screen because I'm trying to display two things, the PDF and my presentation, so that we can be able to go through the homework. And I'm asking you guys, how is electric circuit so far? It's not bad. It's okay, ma'am. I just need to get used to it. Okay, and how is the homework? Who has tried the homework? I have seen only one person submitted the homework. Others, how's the homework so far? How's the homework so far? Guys, how's the homework so far? Others, what are you saying? I have 13 or more of you in this chat, but you guys are not saying anything. How are we supposed to go through this lesson if you guys are just quiet? Because I want you guys to actually do the questions and tell me what you got and how it went, what challenges you had. But you're so quiet, guys. You're so quiet. Okay. It's been fine actually. Okay, it's fine. So let's start with the homework discussion. We're going to start with question one. And I want you guys to do it with me. I don't want to be the one doing the questions today. Since we've done few lessons together, you know the equation, which equations to use, you know how to tackle these questions. And since it was homework, you had more time to actually try it. And the reason I'm doing this, guys, is so that you see how to tackle different questions, to see how to work. Because the aim is not for me to come and do the questions, but for us to interact so that you guys able to feel confident on what you write. So that even when you're writing, because you guys are preparing for prelims, which are pretty close than we expect. So let's start with question one. Question one, we have an electric circuit diagram. As you can see from the electric circuit diagram, 1.1 says a 12-volt battery is connected to two series resistors of 5 ohm each. The voltmeter reading across the battery drops to 10.2 volt as soon as the switch is closed. Calculate the internal resistance of the battery. Who wants to try this question, or what answers did you get to be the internal resistance? Who wants to try? Or must I pick anyone? Must I just call anyone's name? Who can help us do 1.1? Or can I just... Yes, 1.1. What answer did you get from what on 1.1, and how did you do it? Obakeng, are you willing to try? Yes, you can unmute your mic. Obakeng? Yes. What do we do? How do we solve for the internal resistance for 1.1 from what we are given? Okay, what are we given? So what is, okay, so what is, we have the battery of 2 volts, yes. Okay, yes. Yes. So what do we do first? Yes, please give me the formula. Okay. Okay, and what's next? By the R, so you said R here. Okay, P over R, and then Do we have power? Are we given the amount what power is? You see, identifying the equations to use is very important. Thank you, Overgang, for trying. I'm sure I am glad that you tried and you noticed that no, something is wrong. So okay, let me explain how it actually works. So in this case, you have 12 volts. What are we given? I'm going to write what we are given first. You have an EMF of 12 volt. This is from the battery. They also gave you the resistance of the resistors that are in the circuit. So you can say you have R1 and R2. They both equal to 5 ohm. And what else are you given? You are told that the voltmeter reading across the battery drops to 10.2 volt. What is this voltage or the potential drop? It is the voltage of the external resistance. Hence, the external resistance is going to be 10.2 volts. What else are we given in this case? I think that's all that we're given. So the first thing that you can do in this question, because they want the internal resistance, but as you can see, you don't know what the total resistance of the circuit is. So the first step will be to say, let's get the total resistance of the external. How can I write this so it makes sense? Okay, I'll just write, we need the total resistance of the external resistance. So this is the total resistance of the external. Let me just write external. And we know that external is represented by a capital letter. So how can we do that? We can add R1 plus R2, and we know that 5 plus 5 is going to be 10 ohms. So this is the first step that we can do. And with the second step, now we know what the total resistance of the external resistance is. We can go ahead and calculate for the current that passes through the external resistance, because what do we have? We have the potential difference and we have the external total resistance that passes through the external. So therefore, we're going to say, use our Ohm's law, which is I equals to V over R, which will be equal to, you substitute your 10.2 divide by the total, which is 10 resistance, and what will you get? 1.02 amperes. Now that we've calculated for the current of the external, we can be able to calculate what the internal resistance is. If you remember, the equation is the EMF is equal to the current of the circuit being multiplied by the external resistance plus the internal resistance. I hope you remember this equation. Now we are given what the EMF is 12 volts. We just calculated the current. We know that it's 1.02, and we know that the resistance of the external is what? It's 10, so it's going to be 10 plus R. And from here, we need to make R the subject of the formula. And when you make R the subject of the formula, what you will get will be 1.76 ohms. So to answer 1.1, your internal resistance is going to be 1.76 ohms. Are we together, guys? Do you understand? I see Kalia got the correct answer. And others, do you see how it works? Do you understand? Any questions? Jay, do you see where you made a mistake now? Any other question before we move on to the next question? Any questions? Josh, what do you understand? Lynn Rose, do you understand? Luande, do you understand? Mbali, do you understand? I'm going to start calling everyone by name because I only see few people on the chats. And when you're silent, I'll take it as you understand. Okay, now let's go to 1.2. 1.2 says there are two 5-ohm resistors which are now connected in parallel. First they were in series, now they're in parallel. And 1.2.1, will the voltmeter reading across the battery decrease, increase, or stay the same? So what do you guys think? Now you have these two resistors that are now connected in parallel. And the question says, will the voltmeter reading across the battery decrease, increase, or stay the same? What do you guys think? Kayla is saying it's increase. Others, what are you saying? Others, what are you saying? Now I want someone else. Stay the same, stay the same. Others, what are you saying? Let's hear what everyone is thinking. So 2 people are saying it's increasing, 2 people are saying it's staying the same. Who thinks? Someone else, what are you thinking? Do you think it increased as well? Stay the same. Stay the same. Okay, stay the same. Okay, it looks like stay the same is dominating. So now I want you guys to take note of something. Now you have your resistors in parallel. And do you remember what did we say about resistors in series or in parallel? And you're saying it will remain the same. From what we have, you're saying that the voltmeter reading will remain the same or it will increase. And the answer in this case, I'll write it here. This is 1.2. It won't remain the same. Why? Because remember, first it was connected in series. Now the resistors are connected in parallel. What does it mean? It means that the total resistance of the circuit will decrease, so the current can increase. And what does it mean? It means that the voltmeter reading of the external, which is the one of the battery, will decrease while the internal resistance will decrease. So the answer is decrease. The voltmeter reading on the battery will decrease. Why will it decrease? Remember the other day I mentioned that if they ask you and they want you to explain what happens in this case, you must give your answers in a point form. So the reason is, when now the two resistors are connected in parallel, it means that the total resistance of the battery will decrease, of the circuit, sorry, it will decrease, and the current will increase. And the last point, you can say that the V external, which is for the external resistance, which is the one from the battery, will decrease, while the internal, which is small r, will increase. So these are some of the reasons why if the two resistors are connected in parallel, the voltmeter reading in the battery will decrease because the total resistance decreases, the current increases, and that there's decrease in the potential difference of the external resistance, and there's an increase in the potential difference of the internal resistance. Are we together, guys? Okay, great. Now let's go to 1.2.2. It says calculate the strength of the current and confirm your answer in question 1.2.1 with a calculation. So now we need to prove what we just said from 1.2.1. So now let's do 2.2.2. Who's going to tell us what's the first thing that we're going to calculate in this case? The current running through but remember, now we need to consider that the two resistors are in parallel. So we can't use the same values we used for 1.1. Do you see it, Jade? Yes. Yes, but for us to calculate... So how will we calculate current? You said which equation we're going to use? I is equals to V over R. Yes, and what are we going to substitute? What's V? And R? Isn't it this 10 for the external? I see how... Yes, I understand. You see, in this case, we were saying R1 plus R2 because the resistors were in series. In this case, we cannot substitute 10 because now the resistors are in parallel. Do you see it, Jade? Yes, so we need to start by calculating the total resistance of the resistors in parallel. So we're going to start by saying 1 over RP. RP equals to 1 over 5 plus 1 over 5, and we'll get the total RP resistance in this case to be 2 over 5. 2 over 5, and remember what I said, when you interchange this you will have 5 divided by 2. Therefore the total, let me write it here, therefore the total resistance of the parallel resistors will be 2.5 ohms. Yes, now that we have calculated the resistance or the total resistance of the resistors in parallel, we can calculate what current is by using this equation. Why? Remember, we just calculated RP and we know what internal resistance is. The one we calculated from 1.1. and we know what the EMF is. But we don't know what the current is when the resistors are in parallel. So this is the equation we're going to use. The EMF equals to the current times the external, or this will be our RP, which is the total resistance in parallel, plus R. Now we substitute what we have. You're going to have 12. We're calculating for I. Substitute your 2.5 plus 1.1.76. And what is the current going to be in this case? You're going to get your current to be, yes, 2.82 amperes. And what did we say? Okay, we'll compare after we're done calculating everything. Now that we have calculated the strength of the current, we need to confirm if our answer with this calculation is correct. But yes, we just proven that when this resistors are connected in parallel, we said that the voltmeter will decrease and the current will increase. As you can see, now the current is 2.82 amperes, while when they were in series, the current was 1.02 amperes. So we've only confirmed one statement, but we also need to confirm the others that we have. And remember, we said the R total will decrease. So when they're in parallel, we now have 2.5. And while they were in series, we had 10. So we've proven 2 of them. Guys, can I ask something? Didn't we discuss that we will combine the classes? Because every time I feel like there are people who forget that the classes are combined. Or maybe you forgot, guys. So I need to remind you guys every time we have a lesson. Okay, but please take note that our classes, as you guys suggested, we combine both A, B, C, D to have class for 1 hour every time we have classes, so we can cover more work. So please make sure that if the class starts at, if your class starts at 11 o'clock or 11:15, please join at 10:45 so that we can have the 1 hour for everyone. Is that okay, guys? Okay, I'll take note of that I have to remind every time. As I was saying that, I saying something? Okay. As I was saying that now we've calculated, we've proven the first 2 points. Now we have to show this 2 as well. And how are we going to do that? We need to calculate what V external is. So I'll use the big R. Now I'll start with the internal resistance. So we're going to use the Ohm's law, and when you calculate for potential difference, you're going to have your current multiplied by your internal resistance. And in this case, you will substitute your current, which is 2.82 times 1.76, and we will get the potential difference of the internal resistance to be, what is 2.82 multiplied by 1.76? We're going to get the answer to be 4.96 volt. And for us to get the voltmeter, the potential difference of the external resistance, we're going to say 12 minus 4.96, and we'll get the potential difference of the external resistance to be what? To be 7.04 volts. Yes, correct. So now, have we proven that the total resistance when the resistors are in parallel decreases? Yes, it does, from 10 to 2.5, and the current will increase from 1.02 amperes to 2.82 amperes, the same as the potential difference of the external resistance, which was given to be 10, decreases now to be 7.04 volts. And the same with the potential difference. If you had to calculate the potential difference using the current and the external, you will get it to be lower, hence it has increased. Are we together, guys? Any questions regarding question 1? Do you see now that when you were doing the homework, it was not that difficult? Just need to put more logic into that. Yes, so even when you're doing the homework, that's the main aim of this questions. So you see that when you were doing the homework, you were on the right track. It's just that you forgot those simple things. And any questions before we move on to question 2? Okay, no questions. So now let's do question 2. Question 2 says, consider the following circuit diagram. We are given an EMF of equals to 6 volt. We have an ammeter, we have a voltmeter, we have switch 1 and switch 2. We have two resistors that are in parallel, and they have the same amount of the resistance, which is 2 ohms. And the question 1, I have to decrease this further. The first question, which is 2. I have to even